So how can you save money, ultimately? As I previously mentioned, there's 5 main cost drivers, but every specification comes at a cost. Where we like to communicate first and foremost is on the environmental and substrate side. So if you don't need to over-specify your environmental requirements, please don't. Most of our filters on the hard-coated end can withstand 300 to 400 degrees Celsius. That's usually more than enough. If you need higher, please communicate that to us and we can walk through it with you. Substrate materials, more commonly than not, we're using fused silica and BK7, which are extremely high grade and perfectly adept for a number of applications. So if you truly need a different type of substrate, again, please let us know, but these 2 substrates are usually an easy way to reduce your cost and utilize what we have as a standard material. More ways to save, scratch dig. Again, these are types of cosmetic effects or imperfections that really don't hinder optical performance all that much unless you're working with a really narrow laser beam or with a high magnification system. Most of our filters can be specified to 60/40 or 40/20. Defense requirements we see a lot on the 2010 to 10.5 size, and we can certainly do those, but again, you're going to have to pay a pretty penny for the higher scratch dig requirements. Again, size and shape. The larger your filter is, the larger the substrate is, the more expensive it's going to be in the long run. So ultimately, if you can use a standard filter or a standard stock substrate, that'll ultimately reduce your cost significantly. Last but not least, surface figure flatness. Again, unnecessary tight requirement here. 20th wave, 40th, 60th wave are things thrown out there in very high demanding applications. In most filter applications, you can get away with a quarter wave performance. Here's an easy way to understand coating cost drivers from the left to the right and from the top to the bottom. You'll see increasing cost. The way we like to define this, as I mentioned previously, is from commercial to precision to high precision, and what that ultimate constraint would be. So for glass type, your constraint would be lead time. For dimensional tolerance, your constraint is yield. For thickness, it's yield. For size and shape, it's yield as well, and lead time. For surface quality and surface figure, again, it is yield. And then once we get to a spectral profile, where cost is really an increasing factor, the slope of your filter, the overall spectral tolerance on center wavelength, full width half max, or edges, your blocking, so jumping anywhere from OD2, it's usually starting at OD2 and going up to OD6 or higher, your cost will increase significantly, and laser damage. These are being integrated more and more into laser applications for, again, biomedical applications and automation applications, so we're starting to get a better understanding and specifying laser damage threshold on some of these filters.